this is page 9 in the packet. So if I were you, I'd pause this, do page 9 as best as you can, and then come back here and check. Hopefully it'll make a little bit more sense. So a few things that we have learned is by the degree, we can know the horizontal asymptote. So because the degree is the same, this is in standard form, the leading coefficient, 1 divided by 1, will be our horizontal asymptote. So we can see that that's at 1. Now the rest we're going to have to factor to figure out, but we're going to use the graph, since we already have that graph anyways, to figure out these things, right? So we can see that the vertical asymptote's probably at -1, so that's going to be undefined. Remember, you're not allowed to divide by 0. So by plugging in -1, it's going to cause a 0 in the denominator, which is a problem. At -4, that's our x-intercept, so the y is 0. So just a reminder, when y is 0, we get our x-intercept. Okay, when x is 0, that's going to create our y-intercept of 4. So when y is 0, we have our x-intercept, right? And when x is 0, we have our y-intercept, as you can see. Now, when I look at 2, I can see a hole there. So not really sure yet what's going on, but we have that. And then 5, just to show that, yeah, we get 1.5. So just to kind of analyze what's going on. So, all right, what is the domain? So we can see that the graph goes left. We can see this graph goes left up until -1. And then it goes from -1 until 2, and then we have a hole there, right? So we're slipping right through that hole. And then we go from 2 to infinity. So just visually, you learned this way back when, right? There's the domain. Okay, and we already talked about this. When y is 0, we get our x-intercept. So at -4, we have our x-intercept. And then as we come to -1, we can see the values are getting really big but negative. And as we come from, that's our vertical asymptote. And then as we come to the right, it's getting really, it's going up there, right? Okay, so that's E enough. Okay, G, I gotta factor this. So pause this, try to factor it, but we're gonna get x plus 4, x minus 2. And when I factor the bottom, I'm gonna get x minus 2, x plus 1. Okay. So, if we kind of analyze this, right, if we take x plus 4 and set it equal to 0, that's going to give us our x-intercept of -4, right? And if we take this and set it equal to 0, it's going to give us our x-intercept at 2, but obviously it's not an x-intercept at 2, so we'll talk about that. And then the denominator, we're going to get -1, right? There's our asymptote. And we should have an asymptote at 2 also, which we do not. So what's going on is these actually cancel out. So our x-intercept cancels out with our vertical asymptote, and so it still is dividing by 0. That 2 is still going to cause us to divide by 0, so it's still undefined. But as you can see, it's not an x-intercept or vertical asymptote. It's now a hole. All right. So when you happen to have the same thing in the top and the bottom, anything divided by itself becomes 1. So technically we're left with x plus 3, right? But in the original, okay, if you plug in a 3, so plug in a 3 for every x, right? This used to be x. Plug in a 3, that used to be x, okay? 3 caused a problem in the original, right? 3 minus 3, 3 plus 3 is 6, 3 minus 3 is 0, 3 minus 3 is 0, okay? So it caused us to divide by 0. But because it actually canceled out, right, it's not an asymptote anymore. And as we talked about it, if it's in the top and the bottom, it becomes a hole. And the hole happens where the 0's at, okay? So in this one down here on page 10, because we have the same factor in the top and the bottom, it's going to cause a hole at -2. Okay? All right. So, factoring this real quick, we're going to get x plus 3 over x plus 3, x plus 1. So what's in the top and the bottom cancels out, and we're left with x plus 1. Okay, so just a reminder, 5 divided by 5 is 1. Anything divided by itself cancels out, right? So just a little help on that math real quick. So the x plus 3 and the x plus 3 cancel out, become 1, okay? So this is the simplified form of the equation, so that's important, but we cannot forget that in the original, okay, at x equals -3, we were supposed to have an x-intercept and an asymptote, which canceled out to become a whole, okay? Now the whole, as you can see from the graph, okay, it's not just wherever you want to put it. We can see there's also a y value that it lines up with. So the whole is going to have an x and a y. Okay, so you find the x. Whoa, where am I going? Sorry. You find the x by finding the 0, which in this case was -3. And then you use the simplified version of the original function, right? So simplified, meaning the whole canceled out, to find the y value. So we're going to have to plug in a -3 for the x. -3 plus 1 is -2, so we have -1/2. So this is where the whole will be at for that equation, okay? All right, so let's do this one. When we factor, you're going to have x minus 1, x plus 1, okay? So that's going to cancel out, so our whole is being caused by this x minus 1. So the 0 of that will be 1. So our whole will be at 1. We got to find the y value, okay? So we write it in its simplified form. So y equals 1 over x plus 1 again. This time we're going to plug a 1 in, because we have the x. We need the y. 1 plus 1 is 2, so we're going to have 1/2. That's where our whole's at, okay? All right, so let's do... sorry for the weird noises. Let's do... Let me make up one real quick, so it's kind of like the homework. So let's say that you have x minus 5, x plus 2, and you have x minus 3, x plus 2. All right, so that will cancel out, right? What's in the top and the bottom, it's going to divide out. Anything divided by itself divides out. We're left with x minus 5 over x minus 3, okay? So this part is going to form the whole. This part right here, you can have a 0 on the top, so that's going to form the x-intercept, and this down here is going to form our vertical asymptote. All right, so we're going to have a vertical asymptote at x equals 3, because remember, you can't divide by 0. 3 minus 3 creates 0, so 3 is causing that vertical asymptote. You can become 0 in the top, so 5 minus 5 will make a 0 in the top, causing an x-intercept at 5. So it's okay to be 0 on the top. Those form x-intercepts. The bottom form vertical asymptotes. Now here, x plus 2 was trying to become an x-intercept and a vertical asymptote. As we talked about, they divide out, forming a whole. So remember, -2 is the problem. -2 plus 2 creates 0. -2 is the problem. And then we need to use the simplified version to find the y part of the whole. So we're going to plug a -2 in here, -2 in here. -2 minus 5 is -7. -2 minus 3 is -5. Negative divided by negative is a positive. So our whole will be at -2 and 7/5. All right, let's do another one real quick. So let's say I have x squared plus 9x plus 20 over, let's do x squared plus 2x. That one's not going to work. Sorry, let me think of something real quick. Let's do x squared plus 5x plus 4. All right, so you got to factor that. So pause the video, factor it. You're going to get x plus 5, x plus 4 in the top. And then the denominator, you're going to get x plus 4, x plus 1. Okay. So remember, it's okay for the top to become 0. So all the factors in the top are going to form x-intercepts. All the factors in the bottom are going to become vertical asymptotes because the bottom cannot become 0. Okay, but because we have these two competing, right, they actually divide out and become a whole. So we have our x-intercept, our vertical asymptote, and then our whole. Okay, so our whole is at -4, because -4 plus 4 will make 0. You can't divide by 0. In the top you can have a 0, but anyways, and then they become a whole, right? So we're going to take our simplified form, x plus 5 over x plus 1, plug in a -4. So we'll get a 1 on top and a -3 on bottom. So it'll be -1/3. That's our whole. Okay, our vertical asymptote is going to be at -1. If that becomes -1, we're dividing by 0, which is a problem. And then we're going to have an x-intercept at -5, because -5 plus 5 will make 0, which will cause an x-intercept, and it's okay to make 0 on the top. All right, now, that's pretty much it. There are some on the homework that are like this, though, so let me just, hopefully you're still with me. If not, too bad, right? So on some of them, you're going to have something like this. Okay? So what's going to cancel out is this x, right? So we're going to have a whole. Well, if that x becomes 0, right, then it'll multiply. So if this becomes 0, it'll multiply to that, and 0 times anything is 0, okay? So x cannot be 0 on top or bottom. On the top, it would have created an x-intercept. Bottom, it's going to create that whole, okay? Now I need the simplified form. I'm going to plug a 0 in for the x, so that's going to give me 3 times -2. 0 plus 1 is 1, so that's going to give me the whole at 0.6, okay? Now my vertical asymptote is going to be from here. It's going to be at -1, and then my x-intercept is going to come from here. It's going to come from 2.